Solving two-step equations. Alright, so before we start with two-step equations, let's back up and look at one-step equations real quickly. In a one-step equation, we can see that we have two sides of an equation. The sides are separated by this equal sign right here. So I just draw a line down there to separate the left side from the right side. Okay. Alright, so in order to solve this one-step equation, I need to isolate the variable. The variable is the letter. So isolate just means to get it by itself. So I want to get the x all by itself in this problem. So to get that by itself, I need to take that minus 5 away. So I can't just take the 5 away completely, but what I want to do is I want to make it balanced still. So I'm going to take that 5 and I'm going to do the opposite to it. So instead of minus 5, I'm going to add 5 to both sides of the equation. Right, it's just like a balance. If I do something to one side of a balance, I have to do it to the other, or else it won't stay in balance. So when I add this negative 5 to this plus 5, when I combine those, I'm going to get 0. So I'm just going to go ahead and cancel those out, and then that leaves me with just x all by itself on this side. Then I put my equal sign, and then I'm going to combine the 9 and the 5 over on the right side, so 9 plus 5 is 14. And then I can easily check this by substituting this 14 back into the equation for x. So right here it tells me that x is equal to 14. So I'm going to take this 14 and I'm going to substitute it right here where the x is at. So let's do that. We have 14 minus 5 equals 9. And that is a true statement. Alright, so let's go ahead and look at solving two-step equations now. So when I go to solve a two-step equation, the first thing that I do is I look to see what type of operations are in this equation. So right here I have 2x, so that means 2 times x, so I have some multiplication there. And then I have minus 3, so that's subtraction. So when I go to solve it, I go ahead and draw my line separating my left side of the equation from my right side. So after I do that, then I work backwards for order of operations. So I want to take the lowest level operator, so addition and subtraction, and I want to get those things away from the x. So I want to isolate the x, so I want to get rid of this minus 3 right here, and this times 2. So I work it backwards. I take the minus 3 first, right, that's the lowest operation, and I'm going to get rid of that or make it 0 by adding 3 to both sides of the equation. So plus 3, plus 3. Okay, so right here, this is going to cancel out. Negative 3 and a positive 3, when I put those together, that gives me 0. So all that's left on the left side of my equation is just this 2x. Okay, so 2x. Then I have the equal sign between it. And then I'm going to combine the 12 and the 3 on the right side of the equation. Okay, so 12 plus 3 is 15. Then I'm going to take this 2x. So I wanted to get x all by itself. So in order to get rid of it, I have to get rid of that 2. And that's multiplication, so 2 times x. So if I want to get rid of multiplication, I have to do the opposite operation. The opposite of multiplication is division. So I want to divide both sides of my equation by 2. Okay. So over here, 2 divided by 2 gives me 1. So I'm left with 1x equals 15 divided by 2 is 7.5, or 7 5/10. Alright, let's go ahead and look at this second example. 5x minus 4 equals 6. So the first thing that I want to do is I want to identify the operations. So here I have 5 times x, and then I have minus 4. So once I've identified those, I'm going to split my sides. So I have a left side of the equation and a right side of the equation. And I want to isolate the variable, so that means I just want to get that x all by itself. So that means I need to get rid of the minus 4 and the times 5. So in order to get the minus 4 out of there, to get rid of it, I need to make it 0. So I do that by adding the opposite. So instead of minus 4, I'm going to add 4. And since it's a balance, whatever I do to one side, I need to do it to the other. So I'm going to add 4 to the other side as well. So over here I'm left, well, once I get the negative 4 and I add the 4, I'm left with just 5x all by itself, and that equals 6 plus 4, which is 10. Alright, so now that I have the 5x equals 10, I still need to get rid of that 5 because I want to isolate the variable. I want the x by itself. I know what 5x's is equal to. It's equal to 10, but I want to know what 1x is equal to. So in order to get 1, I need to divide 5 by itself. Okay, so I'm going to take 5 and divide it by 5. And then if I do it to one side of the equation, I do it to the other. So we're going to do 10 divided by 5 on the right side. So 5 divided by 5 is 1, so that leaves me 1x. And that equals 10 divided by 5, which is 2. So x equals 2. Okay, here's another example. In this example, we have 3/4 x, so that's 3/4 times x, plus 6 equals 18. So I have multiplication, the 3/4 times the x, and I also have addition, so plus 6. Split my sides. I have a left side of the equation and a right side of the equation. On the left side, I want to get rid of the lowest type of operation first, so I want to get rid of the adding 6, or the plus 6. So in order to get rid of that plus 6, when I say get rid of it, I mean I want to make it 0. I need to subtract 6 from that side, and if I do it to one side, I do it to the other, so we subtract 6 from that side as well. When I have positive 6 and I add a negative 6 to it, that gives me 0, so I'm left with 3/4 times x equals 12. Okay. Now I've identified this as multiplication, so I know that I have 3/4 of x, and I want to have 1x. So in order to get that, when we have a fraction like this, we have to do something called multiplying by the reciprocal. Okay. So I'm going to take the 3/4 and I'm going to write the reciprocal, which is just taking the fraction and switching the places of the numerator and the denominator. So I'm going to take the 4 and put it on top, and I'm going to take the 3 and put it on the bottom. And the reason we do this is because if I multiply the 4 times 3 on the top, and I multiply the 4 and the 3 on the bottom, I'm going to get 12 over 12, which anything divided by itself is going to equal 1. And our goal is to get 1x by itself. So I'm going to take that reciprocal and I'm going to multiply it on this side of the equation, and I'm going to multiply it on this side of the equation. Okay. So when I multiply 4/3 times 3/4, I'm going to get 1x equals. Now here I have multiplication of a whole number and a fraction. The easiest thing to do is to change the whole number into a fraction, and to do that we just put it over 1. So I didn't change the value of the 12, I just changed how it looks. So I have 12 divided by 1, that's still 12, right? But in order to multiply it times the fraction, I need to have a numerator and a denominator. So when I multiply this out, I'm going to get 12 times 4 is 48, and then 1 times 3 for the denominator, and that gives me 3. Now if I can, I want to simplify this fraction. So I have 48 divided by 3, and if you put that in your calculator, if you work it out by hand, you'll find out that x is equal to 16. Alright, in this next example we have x divided by 3 plus 2 equals 5. So I've identified what's happening here. I have division and I have addition. So I'm going to split my sides up, and I'm going to get rid of the lowest level operator first, which is the addition. So we're going to get rid of this plus 2 by doing the opposite, or the inverse operation, which is minus 2. So I'm going to subtract 2 from both sides of the equation, or add a negative 2 to both sides of the equation. This cancels out, that makes 0. So I'm left with x divided by 3 equals positive 3. We said that this was x divided by 3. So in order to get rid of this division, I have to do the opposite, or the inverse operation. So instead of dividing by 3, I want to multiply both sides by 3. So we're going to put a 3, or we'll put this in parentheses, and we're going to put a 3 outside, and we'll do this as well. Okay, so we have 3 times x divided by 3 and 3 times 3. When I take this 3 and I multiply it times x, and then I divide it by 3, the 3's are actually going to divide each other out. So 3 divided by 3 gives me 1, and that's where I get the 1x from on this side of the equation. And then over here I have 3 times 3, which gives me 9. So the value of x in this problem would be 9. And we could quickly check that. So if I take the 9 and I substitute it back in for x, right? 9 divided by 3 is going to be 3. 3 plus 2 equals 5. Okay, so what happens if the letters on the other side of the equation, like in this example? So I have my two sides, right? But what about the letter? Before we had it on the left side, and now it's on the right side. Well, that doesn't really matter. We're still going to isolate the variable or get the variable by itself. So I just want to get n all by itself. So I still look at the problem the same way. I have multiplication here, and I have subtraction here. So I need to get rid of this multiplying by 2, and I need to get rid of this subtracting 4. So we follow the same order. We want to get rid of the lowest operation first. So instead of having a minus 4, we're going to add 4 to both sides. Right? So this cancels and becomes nothing. And I'm left with 2n on the right side, and that equals 12 here. So now I know what 2n's is worth. 2n's is equal to 12, but I still want to know what 1n is equal to. So we said that this was multiplication here. So we do the inverse operation, or the opposite of multiplication. So we would divide by 2. 2 divided by 2 is 1. So we have 1n equals, and we divide this side by 2. 12 divided by 2 is 6. Alright, another equation here. So I am going to split my sides. I have a left side and a right side now. And I want to identify the operator. So I have, or the operation. So I have negative 3 times p, and I have a minus 1. So I start with the lowest level operation, which is the minus 1, or subtracting 1. And I want to make that nothing on this side by adding the opposite. So negative 1 plus 1 would give me nothing, or 0. And I'm going to do it to the other side. So 14 plus 1 is 15. 15 equals negative 3p. Now that I've gotten rid of the lowest level, I need to get rid of this multiplication of negative 3 times p. So in order to get rid of it, I need to do the inverse operation, or the opposite operation. So instead of multiplying by a negative 3, I want to divide by negative 3 so that I will end up getting 1p instead of a negative p or a negative 3p. So anytime we divide something by itself, so negative 3 divided by negative 3, that's going to give you just a positive 1. So anything divided by itself is just 1. So I'm going to get 1p on this side. And then over here, I want to divide by negative 3 as well, right? So 15 divided by negative 3 is negative 5. So in this problem, the value of p would be negative 5.